Hello everyone. In this video, we will learn the basics of Keil Vision software and a few basic examples to start with. So whenever this application is open, any program which was previously used or previously executed will be visible here. So the first and foremost thing to do is to go to the project option and close the project. Then once again go to the project, click on new Microvision project, then save this project or save this file in the directory. It is recommended to create a new folder and save all the files in the same folder. So time being, I'm going to create a folder by name sample1, and this will be of type UV project X. Click on save, then go to legacy device database, then go to microchip or search in this box AT89C51 and click on OK. We can copy the startup file, so click on S. It says that the file already exists. Do you want to overwrite? Click on S. Then this is what we get once we are through these steps. Now we can open the editor where the code can be written. That can be done by clicking on file and using this new option. This is a text editor where the code can be written. Let us write a very simple code to add two 8-bit numbers. I'm loading 23 hexadecimal number in R0 register, and R1 register is loaded with 12 hexadecimal number. Hash signifies that this is the immediate value. The instruction for adding these two numbers is add. We cannot add the numbers when they are in the registers. So in order to perform any ALU function, we need to bring these numbers into A and B registers. So the content of R0 is loaded in A register and the content of R1 is loaded in B register. This is now added with the instruction ADD, which is nothing but the opcode for addition A, B. So this instruction performs the addition between the value that is stored in A and the value that is stored in B, and then stores back the value in A. A is called as the accumulator here. So let us see how this program works. Once we have tagged the code, save this code with the extension .asm. Give any name. I'll give the name as add1. This extension is very much important, .asm, which is nothing but the assembly code. Then click on save. Then go to this target, click on this plus button, go to source group, right click on source group, choose the third option, add existing files to group source group 1. Then find the file which we have just now saved, that is add1.asm, and click on add and then close. After this, we can see if there are any errors. To do that, first click on translate. This translates the assembly code into a stream of zeros and ones, which is understood by the computers. So click on translate. It says that there is a warning, and the warning is at line number 5. which is signified with this which is given within this bracket. Warning can be ignored. If there are errors, then we have to remove the errors and once again save the code and click on translate. After translate, click on build. There are 0 errors and 3 warnings. As I said, warnings can be ignored. Once we are through this step, go to target, right click on this, choose the option. This is the clock frequency 11.0592. Then go to output and click on create hex file. Then click on OK. Once again save this. And now we can execute or we can simulate this code. To check the output, go to debug, click on start or stop debug session. Here you can see the view of registers. These general purpose registers from R0 to R7 are displayed here. A register, B register, stack pointer, then DPTR, then program counter, states, then program status word are all visible here and they can be viewed in this window. Let us execute this code. There are two ways by which the code is executed. We can either choose this option step, which executes line by line, or we can execute the whole code in a single click. So this code is nothing but the addition of two numbers 23 and 12, which should give us the answer of 35 hexadecimal. Let us see what happens when we execute this line by line. In the very first line, the 23 hexadecimal number is loaded in R0, as you can see here. In the next line, 12 hexadecimal is loaded in R1. The content of R0 is loaded in A register. The content of R1 is loaded in B register. And next, these two numbers are added and the value is stored back in A register. As you can see here, the answer is now available in A register. This is one way, or else I have reset the debug session here. So if you click on this run, in a single click the code will be executed and the final answer will be available in the destination register. So this is a simple code to add two numbers, and this is the way by which the code is written and it is executed.